I'll start with, again, I think you all more or less have an idea of what ShapeDiver is, but just, I think some ground concepts, starting slow is always a good idea. So what does it mean to have a parametric definition in Grasshopper and to want to use this as the basis of a web application? If you look at the core things, there's two fundamental elements that a definition has: inputs and outputs. Right, so you control parametrically an algorithm, you input some data in it, and then you get outputs, which can also be data, or most of the time in Grasshopper is geometry, or could be also other things. So I always start with my hello world, and again, you'll be reminded quite a few times today that I'm no designer, no architect, no engineer. I'm just a geometry guy. So I tend to have abstract examples. But my hello world in Grasshopper is the sphere with a slider. Let's say I'm going to edit the slider a bit more. And this already shows the two main concepts that the two main ingredients of every Grasshopper definitions. You have an input that you can control. And this input is, well, a value, but also a set of properties, right? So you can here, for a slider, you have a min-max range, you can only use integers if you want, etc. So there's a set of properties. And on the other side of the definition, you have an output. In our case, it's one mesh, right? I can control how many vertices it has and stuff, but it's essentially, it's here in our case, geometry that we use for visualization, or could be for production if we like a 3D printing application or anything. So these two elements are really anything you need to have a sort of data flow that you can then use to turn into a web application. Where you have the same data flow, you let users input data and you get back results. In our case, if we look at components that have the preview turned on in the Grasshopper canvas, they turn into geometric visualization in the online viewer of ShapeDiver. So actually, this definition, if I save it and I upload it to ShapeDiver, it's going to work. So you don't need more to get started. As long as you have some sliders and stuff, basic stuff, and geometry that is previewed, then that's something that you can interpret on the view on ShapeDiver, and that will result in already what we call a ShapeDiver model, which is a rudimentary application. I think I have to reduce that, so I'm not going to see anyone anymore. But please, I forgot. So I like when it's hands-on. So if you follow and you do stuff at the same time as me, that's great. And you can interrupt me at really any time if something is not clear, or if you have questions about your own applications or anything you want to implement or develop. So I was a bit lazy right now because I already did the whole uploading part in the first workshop, but I think it's important to show it at least once. So if you sign in to ShapeDiver, so you can create a free account if you don't have one, and a free account is enough to do pretty much everything we're going to do today, so that's enough. But you can also start trials to accounts in case you want to embed your models, share them and stuff. That's more what is in the paid accounts. The people at TT have an organization account of ShapeDiver, so you don't need to create, you can just use well, it's not the same SSO login. I think you have a TT specific login link. And even if you've never used ShapeDiver, you can enter your mail address and you'll be redirected to an account in the platform. Okay, so I'll log in again to my account. And essentially, before we look at like the library and different platform things, the main, let's say the star of the dashboard is the button on top where you can upload your definitions. And here I can upload the definition. So if I save this definition, right, I can upload it. Again, different for TT or organizations, they have their own systems, but if you just have a normal, let's say normal free or paid ShapeDiver account, you have the choice of different backend systems to upload your files. Not as much as mine because they're all test systems, but you have at least a Rhino 8 shared system and the Rhino 7 shared system. So depending on the version of Rhino that you're using, it's safer to upload to the server that has the same version because there's some backwards compatibility issues sometimes. So here, if I look at the upload page and I upload my hello world, I think in the last webinar, I made some changes. So I'll just save this one and upload it. Right. I wish I had 2 screens for this webinar, but I'll make it happen. Here's one. So once you upload your definition, what it does is that it's stored securely on our server, so no one can access it. And the first time we are checking the definition to see, essentially to see if it's going to be allowed, right? So it might not be allowed because of some operations that you do in Grasshopper that are not allowed. I'll go back to that in a minute, as in a core concept. Or because we don't support. So there's a lot of reasons why it doesn't make sense in the context of ShapeDiver, or it cannot run. For example, we support a lot of third-party plugins, but not all of them. And if you're using plugins that are not installed on servers, then the model will get rejected. But if you keep it simple, like I did at the beginning, at least it should work. That you get your model here, and you can start interacting with it. So actually, right now I'm in the edit page of the platform where I can change some rendering settings, customize a bit how it looks. But once I save the model, I'll be able to look at what we call the model view page, which is and was for many years in ShapeDiver the only way to interact with ShapeDiver models, so with definitions on our servers, is this page here where you see a big viewer with your displayed geometry and all your parameters here in a panel on the right. So that's essentially, again, the core ingredients of what makes it work. But obviously, that's a bit limited for a number of reasons. The first one that we could think about is that the geometry looks cyan, and it's a default rendering here. And that's not great. You might want to update how things look a little bit to customize. And that's where we see, so we wanted from the start to make ShapeDiver work without having to download the plugin and stuff, just with your existing definitions almost, a couple of tweaks and upload and it works. But obviously, for more specific things, we felt the need pretty fast to have our own plugin to allow for a bit more in-depth operations that are not possible otherwise. So the first one is that the first category of components we have on ShapeDiver are the display components. There's a lot of components here, some other ones. The most recent one is this GLTF2 display here. And if you start using those components, you can tweak a bit your the materials and the rendering. So I can send it to this component, use a custom material, now with the material of my visualized geometry online. So it works a bit like the custom preview and Grasshopper materials, which you might know from Grasshopper, the standard components here. But it does more because it's materials that are specifically optimized for online rendering, and that include other things. For example, all the metalness, roughness, workflow textures. So also opacity textures, color texture. So for example, that's the first thing I can do here is get any sort of texture here. So I'm gonna, well, you can just reference the URL. Is that what the URL? Does it work? No. Okay, I need to find the URL that works. Should have kept the one from the last webinar. That's also not the one. I need to copy that. I copy image address. That makes sense. Image address. Here. Okay. So I input that in the color texture input, and I get my texture. Obviously, I can manipulate my geometry and the texture coordinates for it to look a bit better, but that shows the idea. In this case, it's referencing from a URL, but we also have a bitmap routing parameter in the plugin that allows you to internalize images. Sorry, I need to import it using the import bitmap components. And then I can internalize the bitmap in my definition. So I can just use it directly. So that's also an option. So here we already have some control over the outputs that we have. So the geometry displayed in the viewer, that's made available by the plugin.
Hey, Matthew,
Yes.
I was just wondering if you wanted to change like the scale of the bricks, for instance, in that image. Like, is there a way how do you control that?
Yeah, you can control that by, so essentially it's every mesh, well, not every mesh, but at least the mesh is created with a standard Grasshopper component, become with texture coordinates, right? So here it's using the default texture coordinates, but you can change them a bit. So for example, we support human, the plugin, and if I find it, human, it has a few handy texture mapping components. So for example, we can do a spherical mapping, and then you can scale a bit. So it's P base plane. Okay, so if I put XY plane, and now if I scale my plane, or I think we have also in the plugin. I didn't use that in a long time. I don't work with materials too often, but yeah, transform. Yeah, I can transform the UV textures. So let's say here I can, for example, that's a transform. So I can scale. Okay, I'm gonna remove all these dirty components in a bit, but if I do factor 10 in both directions, right? Factor, and if I input the transform, and then I can probably now. So as you see here, we already have the same geometry several times. And just to mention briefly, that's important in ShapeDiver, everything that has a preview turned on ends up being shown in the viewer. So if you have all these standard components with a preview turned on, they show as this cyan material that you've seen in the viewer. So one thing that's always a good idea when you're done, preparing your definition is to select everything, turn preview selected up for everything, and only turn it on for the components you want it. So for example, the display component. But here, if I change the factor, yeah, I'm able to scale the texture, and that's it.
Cool.
Yeah. So well, I'll leave the slider. Why not? So that's one type of output that you can have in your definition. But the second thing is, if we look, and again, like with with ShapeDiver, we try to like replicate some things you can do in Rhino, obviously. So here I have my geometry that's in my viewer, but I cannot really do much with it. So what if I want to also export? So bake like I would bake geometry from my definition. Well, here is where we have specific components to export files directly from the online viewer. So we have this outputs category, which has a lot of different ones. But essentially, if you use the download export component from the outputs category here, you can send any geometry you have in your definition in the data here. and pick a file format. We don't support all of them, but the most common ones. For example, I could want to export an OBJ file here. And I have the export options, right? So the same, they replicate the ones that make sense from Rhino. So I export to OBJ, and I have a few options I can quick. And I can give the file a name. Here, export. And this will create a way from the online model to export this geometry. I'll do a bit more, a couple more things in the model now, and we'll upload this and see how it looks on ShapeDiver. I just wanted to show essentially the symmetrical component to this export component, which is the import components we have. So in my case, import geometry, for example, which allows symmetrically to import files into the online application and then process them once they're there. So that's essentially the equivalent component to the import 3DM, the standard Grasshopper component, which obviously does not work on ShapeDiver, and that's one of the first examples of non-allowed operations, disallowed operations on ShapeDiver, which is components that reference the local file system, right? So this component imports the file that sits on your hard drive, on your local hard drive. And obviously, if you upload this Grasshopper definition, it's going to lose the link to your local system, right? So that's why these import and export components that we have, they translate this sort of workflow to the context of the web application. So in my case, let's say I want to replace my simple sphere here with geometry I import, and then I'm going to scale, let's say, factor. And to do that, I can use this component. And as soon as I use it, the import feature is going to be part of the online model. So I can rename this, by the way, all the inputs that I have here to scale factor, for example. All the names I give to my inputs are the names that are going to be used on the ShapeDiver. Okay, all factors, texture factor. Actually, I remove the mapping because I'm not going to use a sphere anymore. So this one goes. And here I prepared a file. So this component obviously is meant to be used online, but it still lets you reference a local file just for testing locally. And here, for example, I created 3 boxes. So the first time I opened the file, takes a minute. I'm not sure why it did that today, because it's a very small file. Normally it's instant, but okay, it's here. And now I can see, so I just imported the 3DM file into my Grasshopper definition. So again, just like the import 3DM component works. And now obviously I can use the meshes that were exported and maybe scale them with this thing. Okay, and send them to the display component again. And we already have a workflow that exposes, let's say, the fundamental inputs and outputs that are useful in almost all applications on ShapeDiver, right? So I can use sliders, swatches, value lists, so most of the traditional inputs in Grasshopper. But on top of that, I can also import files using the ShapeDiver plugin. I can also, here we have also a direct text input that allows users of the online model to enter text, and then I can use this text in my definition to influence it. And on the other side, we have a display component that creates, if you're familiar with it, GLTF files, which can be used also through APIs to do other things, but in ShapeDiver, we use them in a viewer to display the geometry. And we have geometry here. And we have an export component which allows to export the file after it's processed. So if I try to upload that, it should pretty much conclude let's say the general principles of ShapeDiver, which have been there for a few years now, and provide a nice segue to the more interesting parts that we're going to see today. So again, I should pass the model checking because I did not use anything problematic. By the way, I can use this a minute to go to the settings. If you go to the settings in the ShapeDiver dashboard, into the backend section, this is where you can switch your backend. So for normal users, run a 7.8. For TT, I think that's just one backend for now, but there's going to be two in the future. And once you've selected the backend and enabled it, you can see the list of plugins with their versions that we support, right? So anyways, if you upload a file with a plugin we don't support, you're going to get a very clear error message about this. But here you can have a look at what's already there. It's quite a few. So I will go
Is
back.
that, oh, sorry, can I ask
Yeah.
a question? Is
Yeah,
that
please.
setting per file, or is it a single setting per user?
You mean those what I just showed about the backend, or you mean in general the settings?
Yes.
So here
So
that's what you're able to do here is to switch which backend you're uploading your files to, right? So you can,
Right.
if your account has access to several, you can switch and you can upload your files to different backends. But here, once you've selected the backend, here this list is the list of plugins that are installed on the servers of this backend system. So that's for all users using this system, they can use these plugins, right? Was that your question, or did I misunderstand you?
Sort of. So basically, let's say I have a project that's in Rhino 7. I want to upload that Grasshopper file, but then, a couple months later, I'm using Rhino 8. If I change this, then I upload the Rhino 8 file. Does that affect the previous one that was Rhino 7?
Well, right now there's no, that's something we'll have in the future, there's versioning, but
Yeah.
right now there's no versioning anyways. So when you
Okay.
upload a new model, it's a new model. It doesn't affect the previous model you had there, right? And anyways, if you switch to Rhino, so if you had a model in Rhino 7 and you uploaded it to the Rhino 7 backend, and now you're switching to Rhino 8, you probably want anyways to have a separate model that's uploaded to the Rhino 8 backend.
Yeah.
Because if you use Rhino 8, I mean, it's the same as locally, right? If you work in Rhino 8 and you do everything there, and you try to open this model in Rhino 7, you can have problems. So it's the same once you upload. Yeah.
That answered my question.
Yeah. Please. So sorry, did someone want to ask another question, or did I understand?
But we cannot change it,
Any more
right?
questions?
Who can change the backend?
Sorry, one more time. I didn't get that.
So let's say I want to change my backend from Rhino 7 to Rhino 8. How can I change it? Can I change it personally, or I need the?
So you can go to the settings here and to backend, but you, Jason, are part of the Thornton Tomasetti organization on ShapeDiver, and right now you just have access to one anyway, so you cannot switch it. But I know we're preparing to add a Rhino 8 backend, so there's soon going to be a Rhino 7 and Rhino 8, and when that happens, you can go here in settings backend and you can switch between the two here.
Oh,
Yeah.
so you have to be the administrator of our organization to change it, right?
No, the administrator can change the default backend. That's right. Right now you cannot, but we're updating the platform, I think, next week, so that all members of organizations can do it themselves as well.
Okay, I see.
Yeah.
Thank you.
All right. So where was my model? I think I got lost a bit. I have to go back. So anyways, even if I left the page of the upload, it's not a problem. It's still happening in the back. And you can go to pending models here. And I should see, I have the list view, but that's the last one I tried to upload here. And I can go and finish setting up the model. in order to publish it. So here we should see the second version, which includes all the other things I mentioned. As you can see, by default, this model does not show anything here because I'm working with this import geometry here, components, and no geometry was imported yet. It works locally here because I reference a local file for testing, but this local file does not exist in the ShapeDiver service, right? So now, in order to play with this model, so you see all the value lists and everything I have in my model there now. And now I can use the import geometry components and import my file. And now the algorithm will process the geometry imported and show an output. And obviously, I can then also play with the other parameters and update the viewer. So here I can scale everything, for example. And I have some other options. And then you can see that on top of the parameters panel, there's an exports and outputs panel that contain that. So this button corresponds to the export components I did here. So here, if I use this button, I can now the servers process the export, and I can export the OBJ file with the options I defined. Okay, if we look at some basic, in terms of basic context, I mean the core principles, that's pretty much what I wanted to look at. We just looked at the import geometry components, but you can also import bitmap files, so images, text, and even streams. If you're building a web application with an API and you want to send a data stream, you can also do that. But in terms of importing geometry, in this case, we're using the headless import of Rhino, so it supports pretty much all the formats that Rhino supports. Okay, so now we can look at, again, at the, well, I can save it and we can look at the final app. I have, in a sense, I already have like a fully functioning web application, right? I have a visual application with a viewer that shows results. I can import geometry from it, export geometry, play with parameters. And depending on the ShapeDiver account, so with free accounts, sharing is a bit restricted. You can make the model public and then send the link to anyone. But if you have other accounts, you can keep the model private and create a link for sharing with other users, or enable embedding and embed it as an iframe in your website, for example, right? So you can already essentially build and deploy this simple web application. So here, for example, in my account, I can enable link sharing, which means I can keep my model private. No one else can see it on the platform, but I can generate a link like one would do for a Google document or something, where only the people with the link can see it. So that's one way of sharing. Another way is to share it directly with other users that have a ShapeDiver account, of course. But of course, everything I do when I do that is share this page here that I have, which contains a lot of, it's embedded in the ShapeDiver platform. It contains a lot of additional information about my model, its performance, and computations, and essentially the layout of my web application is defined by the way this page looks on the ShapeDiver platform. Right, so I have an application with on the left a viewer, on the right a list of parameters, which you are able to order and group together using some simple principles. So the principle for ordering parameters on ShapeDiver is just top to bottom on the canvas. So depending on the order in which you have all of the parameters here, it's going to order them the same here in the parameters panel. And for grouping, you can group them using Grasshopper groups, give name to the groups. So that's some level of control over the layout, but it's still quite limited. It's limited in a few ways. Well, first of all, it's limited in a very obvious way, which is that the layout is fixed. I cannot build an app with like you know, a container on the left, on the right, on top, hide, and the second thing is that the interface is not contextual, right? So I cannot use the state of my Grasshopper definition and what's happening there to show different things in my interface to adapt to what's happening. So the geometry is parametric, but the interface is completely static. And the last thing I can say, obviously, it's a bit obvious that I'm introducing some features that are part of the app builder, which we're gonna look at now. But just to pinpoint, the only thing you can see in this page related to the model is a list of inputs, parameters, sliders, etc., and a 3D view. But obviously, and especially in the context of the AEC industry for engineering apps, you know, early stage planning, embodied carbon, all these type of use cases. What one might want to show other types of outputs as just geometry, that outputs just, you know, numerical, textual, or whatever, or also charts, graphs, you know, make this a bit more lively, make this a bit more user-friendly and useful for, you know, any sort of application in this context. And so what we're going to look at now is then let's say the ShapeDiver, almost ShapeDiver phase 2 now, which is that you know, we're going to go from this very simple type of application built with, you know, the old ShapeDiver components and standard ShapeDiver, standard Grasshopper components, and include inside Grasshopper on top of the logic, the core logic of the algorithm, the definition, and what needs to be as displayed, what needs to be exported, etc. We're gonna build also parametrically the interface of the web application directly from inside Grasshopper, which allows us to directly pull all the logic that already exists in the definition and use it to build a smart, adaptive, responsive user interface for a web application. So essentially building really an end-to-end web application using only Grasshopper. And in order to do that, we can look at the simple example that I put in the Google folder. So in case you don't have anyone, you still want to follow, you can start, you know, start along what I'm working on. And I chose this example because it's going to be able to show, yeah, 80% of what one can do with the app builder at the moment. And it's at the same time, since again, I'm no designer, architect, engineer, it stays very abstract, but you know, there's something good to be said about abstract examples because they can be applied and adapted, or you know, they help to convey the concepts. So sorry if that's a bit simple or annoying or not. Does not look like the type of apps you would build with ShapeDiver, but I think it's a good starting point. So that's my definition. It's a very simple, you know, this sort of halftone generators where I have this curve for the boundary. Okay, so I can create obviously another curve here. For example, a star, and set it here. So it's driving my pattern, and then I can control the size of the cells in the pattern, right? And a couple of other things. And on top of that, I have another geometry driving the algorithm. It's a point which acts as an attractor. So something quite traditional. And on top of that, I have a mode. And here you see, I on purpose did not, well, first of all, because I'm a bit lazy, but on purpose did not organize this definition much, because that also helps to convey that the app builder then helps to start from anything and put some order without having to, you know, reposition everything in the definition and organize them neatly, etc. So here, the other main parameter I have in my model is the mode of the attractor. By default, it's like this point, so spherical attractor, but I can change it to like a linear in the X or Y direction, centered around the point. And what's interesting here already is that all of this is quite simple, but I have a couple of other parameters which are only relevant depending on which mode I selected here. So this invert parameter and also the Y and the factor here, they only have an effect on my geometry if I'm in the correct mode here. Otherwise, for example, if I'm in center mode and I invert, well, in my case, it still works, but okay. I don't remember when I did this definition. But they are meant to be working with the linear mode, right? So that's already some logic that I see that in Grasshopper, I cannot really convey easily. All of my parameters, input, toggles, value lists are always present in the canvas. But in my app, I would like it if some of these parameters only show depending on the value of this other parameter. So add a logical layer. On top of it, so essentially that's one of the things we'll do, add some logic, we'll add some layouts, we'll organize a bit, in different containers in the app, so we'll make a nice interface. And the other things we'll do is add some other elements that you cannot add in a traditional ShapeDiver model. So for example, a text widget that explains a bit how the app works, maybe a tutorial, some information. An image widget that shows a bit the results. And we'll finish with the very recent, so all new ShapeDiver features where we'll be able to replace those internalized geometry elements here with new types of inputs, so interaction inputs that let users directly interact with and create geometry in the online viewer, right? So a little bit like you would here drive your algorithm by updating the geometry in the Rhino document. Okay, so we'll get started. So what is relevant here is this new category of components called App Builder in the plugin. So it's been there in the last few versions, but in case you're currently trying or you want to try in the near future, you can look in the package manager and download the very latest version I would recommend. So it's a 1.21 that we released yesterday, right? So it's available there and you can install it and start working with it. And the first thing that I want to say is also that in this case, the App Builder components, we wanted to have them with as little influence or interaction with an existing definition, so that you can start from an existing definition and just add on top of that builder components to organize it and create your app, but without having to change all the flow and change everything that already exists in your definition. And you'll see as we build the app that it's essentially going to be built on top of what already exists and just create references to the existing inputs and outputs that exist in the definition. And before I start adding the components on the canvas, I just wanted to briefly talk, a bit of theory, let's say theory, quote unquote, about what does it mean that we want to build web applications. Obviously, we're not going to build a generic web applications. We're not going to use Grasshopper to build, a financial application or a to-do list or whatever. We are building a specific type of applications, right? So the type of applications are a visually oriented application that creates or manipulates 2D or 3D geometry, pulls data from it, influences this sort of environments. And it's on top of that, we limit ourselves in this case to single page application. So applications where you have a single screen with different parts of the layout, what we call containers, that can be placed all over the screen in different locations, can be hidden or shown, etc. And all of this is centered around a 3D viewer that shows the result of the geometry. In the future, we'll add an option to not show a 3D viewer because some applications are just using Grasshopper to manipulate data. For now, all the applications we can build are centered around the 3D viewer. And if you think of this family of applications, essentially you can imagine the application as a tree where I have my full app, and then as children of my application, I have containers. I have one container for the viewer here. I have one container for my parameters. And inside containers, you can have several tabs if you want, but that's not necessary. So we'll see that we can add tabs or not in containers. And inside those, we can start adding widgets. And I'd say widget is like the core brick of the app builder features. That's what really allows to build different types of layout elements. So we'll see we have tons of widgets, but for example, there's parameter widgets to add parameters. We have image widgets, chart and graph widgets, etc., which you can organize inside the containers of your application. So let's put this into practice. And starts with the app builder components here. And they're pretty much ordered in the order that you might want to build your application in, starting from the app, so the full app, which is at the end. So at the end, what I want is a full web application. And I'm going to start populating what I want to add to my web application. And the level under the full app is the container level. So I can want to build an app with one or several containers, which themselves are going to contain, widgets. And in our case, so we'll have a lot of templates to allow for like really flexible layouts in the future, and we are still playing with this. It has to be use case driven. But right now, we in the default template, we support containers with 4 different names at the moment. And those names basically say where the containers are in your screen. So you can name your container left, right, top, or bottom, and it's going to appear where you define it on the screen like this. So for example, I might want to add one container that I call right in my app. And now I know that I defined a space in my screen, app screen, where on the right I have a container with space saved to add some UI elements. So here, as I mentioned, I can add tabs or directly widgets. If I add tabs, I can, and that's what I'll do. I'll go through a tab level here and use merge components just to stay clean, and also because then it shows the tree defining my web application very explicitly. So I'm adding 2 tabs in my container. And let's say that in those 2 tabs, so tabs, again, they have a lot, so tabs have names. So that's the names that are going to be displayed in the app. You'll see in a minute. Also icons, the icon can be used in the app itself. A tooltip when you hover over the tab, and then a list of widgets that you can include. So in my case, I'd like to add, let's start by adding in a tab with like the pattern parameters. So that's the name I'm gonna add here. And a tab with file exports. I just have one at the moment, but there could be several file exports in that tab. And in this case, well, I'll just start with one parameter and one file export. And both of those can be added using a parameter widget. So here in my tab, I'm going to add a parameter widget. And a parameter widget can take a list of references to parameters and exports. So exports, we include exports in a parameter widget because they're also these UI elements where you can click and trigger the export of the file. So in my case here, I am adding, for now, I'll just add one. parameter reference. And the way you add parameters here, in this case, so now that I'm building an app, the parameters that are everything that's going to be shown on my screen is curated by those components, right? So at the moment, if I open the app, nothing, there would just be a viewer. There would be no UI. I mean, no, there would be a container, an empty container with 2 tabs, with nothing in it. But here I'm going to start adding parameters, and I can add here, for example, my cell size parameter. And the way to add parameters is to reference them by their name. So here I'm telling my app, I want to show in this location the parameter called cell size, which I defined in my algorithm. So that's for the first tab. And in the second tab, I wanted to also use a parameter widget. In this case, to show my exports reference. And actually, I'm going to also already show 2 controls here, because I have, I forgot to add the export here. Right, so let's do that first. We're gonna display that nicely with a boundary surface. Yes, was a bit long. There's a patch. That should work. So boundary surfaces, I'm gonna make them black. Okay, so here I control what's displayed in my viewer, and I'm also gonna export this list of curves. So I want to export the curves to a DXF file, for example. I might do my export. I call it, again, the names are going to be used in the app. So I'm doing export DXF. I'm sending the curves. And here we have the drawing export options. And actually not export DXF, I'm going to call it export drawings. And leave the format open, export format here. So I can switch between DXF and WG. And here, drawing, so I'll drawing exports. And now I said I want to export, so I'm going to click export drawing, and I want to show the value list here. So I'm going to add it here. Actually, parameters don't have to go through the reference here. They can also just directly, the name can be connected to the widget. The reference can just be used to override some things. For example, the display name, I could choose a different one that I have in my app. The group, the tooltip, also I can add a tooltip. But I can also directly grab that to my parameter widget, and that works. And my export here, export drawing. And I add it here. So here, if we sum up, I have in my app, I have one container on the right that has 2 tabs called pattern parameters file exports. And each of them contain a parameter widget. Here I just have one parameter for now. And this one contains the parameter to change the format and the button to export. So that's like the very basic first example. We can try to upload and see, well, first of all, show how to open the app from the platform. So go from the model view to the final app that we built, and then see how the process. So here, it's also because, this these features are being really developed quite fast. So the model view right now still looks like it ignores all these app builder components. It just looks like it would if you did not use the app builder at all. But on the model view page here, we have an open app button that allows to open this app in full screen. So it's a self-standing app, right? With the interface that we defined in Grasshopper. So in my case, the viewer is empty because I guess, yeah, I did not internalize the boundary curve here. So it's only in my document, and so it remained empty. So we'll have to wait until the next iteration to see the geometry, but it works. But otherwise, we can see that as I define, I have a right container here with two tabs. One tab with just a single parameter here, the cell size, and one tab with my export format, which I can update, and a button to export the file that I created. In this case, it failed because there's no geometry, so there's no file to export. Okay, so that's really building, essentially reproducing a bit with a bit more flexibility, but reproducing the kind of static user interface that the traditional model view page in ShapeDiver was already allowing to do. So the first thing I'd like to do is to add a bit of logic to this and include the logic I mentioned previously. What did I break here? When I updated all of this, I removed some of my logic. Okay, I think I have to go to my final file. This one, yeah. That's the same, but I don't remember. Somehow I deleted, when I added the materials, I deleted this part of my definition. So we'll pick it up from here. And I remove all of this and start again from where I was here. Yeah. Perfect. Okay. So we're back to pretty much the configuration we had before. This is just the lids. Okay. And here, so here we have this logic to change the attractor behavior. And essentially, what I want now is on top of the cell size, I want to display these other parameters here, but at the condition that I'm in the mode that makes sense to show them. So here I'm going to add this. So I have 0 is center, linear x1, linear y2. So I'm going to add a filter, and here I'm going to add, in 0 here, it's the center mode. In this case, I don't want to add these parameters because they're not relevant in my case. But 1 is linear x, and in this case, I would like to add my invert x and factor x. And then if I'm in the linear y mode, I want to show those two. And that should do it. So now, on top of cell size, those are all parameters. So yeah, I can just do it like this. Yeah. And we can see, and by the way, we can always use panels to inspect a bit the content of the app and debug what's happening. Because in the end, the app is just a JSON file describing what's going on. And in this case, I can see that in my parameters widget here, I just have this cell size parameter. But if I change to linear X, I now have 3 parameters, cell size, mirror X. So now I have this additional logic to show, so basically to adapt to the state of the definition and show different, well, a different layout, a different set of options, depending on that. The second thing, let's say, let's add something else to this iteration, and let's say I now on the left, so now I have my panel on the right. I'm also going to add another one on the left. Using the left reserved name. And let's say in this case, I'm not going to use tabs. I'm just going to directly add widget. So that's going to be no tabs. And I would like to add a little text panel with some instructions to my app. To do that, I can use the text widget here that we have and connect it. And essentially, any text that I write here as an input is going to be displayed in a card in a text widget in the app that I deploy, right? So obviously, as for the rest of the parameters and the logic I showed, this text can be parametric, right? So it can essentially show data that comes out of the algorithm. And on top of that, it can be formatted using Markdown formatting, so standard Markdown formatting, which means I can use, I don't know if you're all familiar with Markdown, so please, if you're wondering, or if you don't understand the concept, I can explain a bit more. But essentially, it's a way to format text for HTML with very standard symbols and a lean language. So here, for example, if I use hashtags like this, it's gonna create a heading. So it's a half-tone generator, and then I can add play with the parameters the right panel, and I can also, for example, right panel, I can put it in stars like this, and it's gonna create italics. I can also add color. I can add links to things. So anything that Markdown can do here, can use it to format my text panel. And what I wanted to do is maybe, yeah, maybe it doesn't make sense in the same location, but let's say we do it like this. That's like a bunch of static texts. But let's say I want to add some information about my application. So I can say there are currently links, listings. So there are currently 652 output curves. Not so interesting, but just to show some contextual information. Okay, so here we're gonna upload another iteration just to show. I added logic to my interface, and I added a second panel on the left. And in this panel, I added some text widget for static text, formatted text, and contextual text. And I like, by the way, I do this for the purpose of the workshop, but I like, obviously, we'll try to improve this in the future and have like a sort of live checking of how the app looks and how it's being built. But obviously, here in Grasshopper, we're a bit disconnected from the web environment, so I like to upload frequently and see the progress and see that everything works as expected. Great. So now I internalize my geometry, so I can see it. And I can quickly use the occasion to show how to use the edit page here to tweak some things. So there's a lot of things that can be tweaked here, but I'm not going to look at the parameter panel too much because we're building apps anyways, which allow to do all of this. But here, for example, I'm in a 2D app, so I can hide the grounds. I wanted to, by default, I will hit center. And I can switch the camera to a top level view. So now I'm constrained to top level. And I don't know, I can add a bit of color to the background. So I save that. And now we can go look at the newly generated app. Still by clicking on the same app button here. And we see the new version of the app. So as I mentioned, the new panel on the left, the text input was it's not super well formatted, and I have a bug. I forgot to add a space here, but you can see that here, for example, if I increase the cell size, I'm gonna get a different number of curves, and the text a bit formatted. Here I still have my two panels, and for some reason my export disappeared. That's because I replaced the components here, so it has a different name for export. Here, instead of export drawing. But otherwise, everything works as exported. I'm pretty happy with my app. I can see also that what's good with the builder is that the template is built for responsivity, so it adapts here. It's also good on mobile. It's going to work. So that's something that's built in the template of the first template of app that we included with the app builder. Okay, so I think that's pretty much it for the standard. Let's say the more easier concepts of the app builder. Now we can look at going a bit further, and we can start by looking at the parameter widget. So the parameter widget, no, sorry, that we looked at, I did not want to say parameter widget, I want to say image widget. And the image widget is pretty self-explanatory, but we can use it to, like all the other components that I showed, we can use it to display static. So if we compare, for example, with the text widget, we can use it to display static information, but also dynamic information. And that's what makes the image widget interesting. So the image widget allows, just like I use the text widget to add text in my app, it allows to create another widget that shows an image in the interface. And the first way to use it is to reference a URL here. So any public URL of any image. If you plug it to this input, it's just gonna show this image directly in the interface here, and that's it. So it can be used to, again, with a tutorial, so to display static information, it can be useful. But what I wanted to show is how to use the second input, which allows to display parametric images created inside Grasshopper. I'm not going to go too deep today. I mean, unless that's something that's extremely interesting for you and you have questions. So please, again, don't hesitate to ask. I go a bit fast here. But when you download the Grasshopper plugin, first of all, I showed you already that there is a, or it was in the other definition, not in this one. But the Grasshopper plugin comes with a bitmap, a new floating parameter type. And with that, it comes inside the Grasshopper plugin. So here, for example, image sampler, several components here. But also it comes with the Squid plugin, which we adapted to the context of ShapeDiver. So here. And the Squid plugin is a plugin that allows to basically, using drawing instructions, draw vector graphics, essentially. So in my case, I could use the Squid plugin to create a JPEG, a PNG. PNG is better for the web, of my pattern. So I could take these curves here. So the Squid plugin, I have the Squid component. That's the one that creates an image. And I can tell it, I want to draw in this rectangle. I have a rectangle here. And then give it draw instructions. And for draw instructions, I want to draw the curves. And I want to draw their outline as black. So that works. That's not this one, it's this one. And maybe here I can do something different as in the viewer. So again, I'm going to show that in the interface, which is already the geometry in the viewer, but that's just to make the point of parametric images. Obviously, I could show something different. But let's say I'm creating a bitmap with the curves filled in pink. So here I can preview it with the preview component of Squid. And I can change the resolution, etc. But right now it just has the same size as my geometry in Grasshopper. So here I have a rectangle 341 times 313. And now that I have a bitmap object, I can export it the same way that I export my DXF. The ShapeDiver plugin supports exporting to sorry, not importing, exporting to bitmap formats. So here I can say image export options. And I want to export to PNG. And I don't want to allow this to change. So I'm going to internalize the export options here. I can not. Okay, so I internalize here. All right, and I can give it well, a name of the export file, so not exports. But what's important, so again, I could then add this component bitmap export using a parameter widget that would give me, again, like for this one, that would give me a button to export the image from file. In this case, that's not what I want to do. What I want is to show it in my interface. And it's going to work pretty much the same, but using the image components here. And using the export name, so the name of the export component that I want to show. And I add it here. And here I added, again, a parametric image to a location in my app layout. So that's one more widget. And the rest of the widgets that we have now, and again, like we're iterating fast on this, so there's going to be more widgets coming. But the rest of the widgets here, they're used to display graphs and charts and stuff. And for this model, it doesn't really fit. So I'm going to, when we are finished building this app, I'm going to switch to another model quickly and introduce quickly the app widgets. But they work in a pretty standard way. If you've used Human UI or PDF Plus by David Mance, they are very similar. But the last thing that I wanted to do in our case is to add my other inputs that I have here, which right now I can only control through yeah, I'm again removing this because I had switched to my latest version. Okay. Oh, good. So here, if we remember, so I have all my sliders and stuff that control the patterns, but obviously when I'm in the context of Rhino, my most interesting inputs are the boundary curve here that defines my pattern and my attraction. Right? So I want up now. So go a bit further with the functionality. And that's now possible using one of the very latest components. So we have 3 new components here that allow to define geometry that can be interacted with in the online viewer. So you can define a selection input, which just lets you click on different objects in the scene. A gumball, which allows you to transform, rotate, and translate an object in the scene. And the points input, which we're going to use in this example. So the way it works is simple. If you add this points input to the definition, here I'm going to call it boundary. So it's going to also keep this name once it's in my interface. And it allows to create or edit so a set of points, which can be either in the form of just points, disconnected points, an open polyline, or a closed polyline. In the case of this application, I'd like to use a closed polyline, so I'll stay here. And then I can define a bit more restrictions for the users of the app online, constraining a bit what they're allowed to do with this input, because theoretically they could do anything. So I could add constraints restricted to a plane or to another geometry in the viewer, and I can also define a minimal and maximum number of points that I want to allow to be drawn, to be added or removed to the polygon. So I'll keep the defaults here, and what I'll do is actually also set a default for those for this input. And here, if I click, it's very much like the same as if I would be to right click and set one curve here. Well, except here in this case, it's a polyline, so it lets me draw a polyline directly. So I can draw a different one just to show that work. And you'll see that the component then splits the polyline, or if I switch to points, the list of points that I defined. And now I can connect this and use it as an input in my definition. Well, I'm not sure why it wasn't closing here. Maybe I don't know. Yeah, I noticed that. I think that has nothing to do with the ShapeDiver stuff. It's just my Grasshopper algorithm is not so stable. So I have to be careful where I draw. I'll go back where I was a bit. Yeah. And yeah, and then that's it. I mean, the last thing I want to do is also to show this input in my app. So I'm going to add it also to the left panel here. So let's say here I add a parameter widget. Which is going to contain 2 parameters. Boundary that I just added. And I'm going to add a second points input. But in this case, I'm going to restrict it to a single point. So min and max are 1. I just want one attractor. And use that to drive the algorithm. So here I'm going to call it attractor. And also add it to my app. And I think if I did not make any mistakes, that should be everything I wanted to add. So let's go have a look at this new iteration. And after we look at the result here, I'm gonna take a 5-minute break, which you might as well need, and we'll look at the rest of the features after the break. Or maybe, let's say, if you have questions, let's take them before and then do the break. So here I can quickly show another feature in case, for example, you're doing like me and you're iterating on the same model again and again, and you've taken a long time to set up your scene and position your camera and change things. It can be cumbersome to have to do this every time. So there's a way to import your settings from previous models here. You can search. Here I can, if I put halftone, it's going to show me my previous versions. And that's the last one I had uploaded. So I can select this one and import all the settings. And now I'm in the same configuration as I was. So I'm going to save it like this. And we can have a look at the final app. So how did this tree here has messed up the order of my things. I know. That's 1, 2, 3. I have the text, I have the bitmap export after. But I think here there was a tree. Yeah, I should have flattened before the component here. I'm not sure. My data got a bit messed up. So if you send a list, it's gonna be displayed in the order of the list that you are sending, of course. But here I noticed there was a tree at the exit here, and that was unsafe, but I didn't check. Okay, so you can imagine that it was in the order that we find, but now it's not. It's a bit messed up. But we can see that we do show the image in the image widget as we defined, and that of course it's a parametric image. So I can do this. The image updates as well. We still show here our parametric text that I forgot to fix. And now we also show in the parameter widget those 2 new types of inputs, which allow to control the geometry. So by default, they're not active, right? There's a button here, and I can say, okay, I want now to edit my boundary polyline, so I can click on it. And I get in the mode where I can interact with this geometry. So I can move the existing points, but I can also add new points here in the middle. If I get close to the middle, then pull and add a new point. Or I can select a point and press delete an existing point. And when I'm done, I can confirm, and I get an updated geometry, updated outputs, I mean everything updated. Yes, I also messed up in my versions. I messed up. I'm not showing anymore the same size. Okay. So just to stay a bit on the boundary on the polyline input here, there's a few more options which you can control. We might change how it works and maybe even expose some of those in Grasshopper to set them in stone. But for example, I can, when I update my points, I can use a grid and snap to this grid. Here you can see by default the grid is way too small, but you can use, okay, this one is too big. Right, so I can work in a more precise environment, let's say. Again, my algorithm seems to fail. I should not have drawn a curve apart from the origin, probably. But anyways, the concepts are here. Okay, so in terms of the polyline, that's what I wanted to show. And in terms of the attractor, which we allowed only 1 point in this case, then you can see again, I went a bit too far here. So I will have, anyways, I'll share the version that works obviously in the Google Drive. But I think I went a bit too fast. So I'll go back. Okay, that's the one from the first workshop where the logic was implemented correctly. So here everything should work. And in the attractor, so here I can position it and go move it. Okay, that works before. So that's my first bug of the day, but I'm not sure why. The rest works. Interesting. But yeah, in this case, the attractor is just 1 point. So as you can see, you can place it and then move it and then use it to influence as well the algorithm. I'm not sure why it stopped working, so there must be a server issue maybe. Okay. Yeah, let's maybe if no one objects to a quick break now, 5 minutes, and then before we look at more things after the break, we can start with some questions if you have some things that are already in your mind or that you're wondering about, and then continue with the rest of the content. All right, so see you in a bit.
Great, thanks, Matthew.
Thank you, Matthew. Can you please share the Grasshopper file to the Google Drive?
Sorry, the Grasshopper file to this full example, you mean?
Yeah, to the Google Drive so that we can study that.
Yeah. So it's gonna be in the there's a shared folder for the workshop, which the link should be in the email that you got after registering to the workshop, right? So I already have the
Oh, okay. You updated it, right?
Yeah. That's a file that I started from. So that I started to the demonstration with, and I'm gonna add by the end of the workshop. I'm gonna add the final results.
Okay, thank you. Sure.
Thank you.
So hello again, everyone. I wanted to go back, and I'm not sure what's happening here. That's a bit. Usually the first time there's bugs and then the second time works, but I'm not sure what I did wrong. So I'll take maybe a bit of time after the workshop to upload the right definition, because at least one of them worked, but I have to find them. So that's just a bug in my definition, not in ShapeDiver. Okay, that was another version. Yeah, not sure what happened here. Yeah. Interesting. But okay, I guess that happens. Let's call it a live demo. That's a feature that was released yesterday. So yeah, too bad. Okay, so here, provided that everything works as expected, as we defined, we already managed to build a full UI that does already some pretty advanced stuff in a standalone web application, right? So a web application that can be then used in various contexts. And I'll show a bit how this can be shared. There's various ways to share this app. But I wanted to quickly show another example to introduce. By the way, that's maybe a good time to mention that in case something's unclear or in case you want to dig a bit deeper in some of the concepts that we're looking at now, everything is documented, and there's a list of tutorial models that you can see them, and you can download the Grasshopper definitions, which are properly, very well organized, much better organized than the file I'm using now, and documented directly inside the definition. So here, what we're going to look at is the quick tutorial I have here. So if you look in the Grasshopper App Builder, here every single component is documented. And for example, if I go to the round chart widget, it explains how to define a basic round chart and what all the inputs do. And there's a definition here, which is the one that I just pulled here. And it's this definition of one of these classical optimization algorithms that come with the Kangaroo plugin, where you have optimization of the planarity of a bunch of panels and a couple of parameters influence the optimization factors. And what I do here is something a little, a little also schematic. I mean, it's no real life application here, but here we display a colored mesh with a color that depends on the tolerance, on the planarity tolerance that we get from each panel, so before or after the optimization. And what I do is I added to this algorithm a quick way to separate all panels in 3 categories. Let's say it's a bit also abstract, but panels that can be cold band, odd band, or outside tolerances. So basically 3 ranges of panels. And what I want to do with these 3, and essentially, yeah, here I compute how many panels are per category, right? So without optimizing, I get this, and if I optimize, I get almost all of my panels within tolerances, except a small number, 40. So here I wanted to show that because in this case I built a very simple app with my optimization parameters. So I just have a widget with 3 parameters on the left panel. And on the right panel here, I am using the round chart widget, which is, there's bar charts, line charts, array charts. So there's different types, and they all come with their own settings. And then we have a series of components here that basically make it easy to format data that should be displayed in those charts. So in this case, I use a round chart with this title, Then for run charts, we have several styles. So there's either donut or pie. So if it's like a donut or plain camembert pie. If the labels and the legend should be displayed or not in the widget. And then here I can send the data that I want to display. And here the data, I send it using the round chart data component. And for the round chart, it's pretty simple. What I need is a list of names, a list of colors to show in the chart, and the list of values that I want to show. So I have 3 of each in my example. And if I upload this file to ShapeDiver, try here in my library. I'm not sure that's no, that's okay. That's a more advanced version of this example where I added some selection of the panels. But anyways, the main thing I wanted to show is the chart. So we have here, actually there's even a bit more here. I have the optimize button and I only show the optimization parameters if I optimize. But as you can see, on the right here, I have my round chart and the data displayed is contextual of the state of the definition. In this case, I can quickly show that, but I added also to this app a table, which can be defined using the text widget and Markdown. So that's the table formatting of Markdown is supported, so I can show a table here. And I also added another text widget called selected panel because I have my I added a selection input to this model that lets me explore a bit more and select a panel in my model. And when I click, it sends to my definition which panel was selected. And then here, the only thing I do is just show the tolerance for this selected panel. But obviously, I can also use selection to influence the geometry to do anything I want. All right, so I think that's about everything I wanted to show in terms of current app builder specific features. And I forgot I wanted to have a quick thank you, Aloy. I wanted to have a quick question round in case you had any. So if you wanted to ask something or there's something specific, please shoot, and then we'll look at how to deploy and share the apps that you've created with the components. No question at the moment?
Yeah, it sounds like my question was like, how can you embed this in another website? But it sounds like you're going to get to that with the deploy. Yeah.
It's the next step. Yeah. All right. Well, that's good. That either means I lost everyone or that everyone understood everything. So I can move forward to the rest of the workshop. And I actually went quite faster than the first one. So let's see, but I feel like I might be able to release you before the end of the 3 hours this time. Okay, so let's go back to the ShapeDiver platform. So as you've seen a bit at some points at the beginning and at some points of the workflow, I'm now in the ShapeDiver platform, and if I go there, I see my entire library of uploading models, right? I can even perform so I can even open the app directly from here if I want and go this link. Or delete. I can always also download again the Grasshopper definition, which is a good way to manage a library of Grasshopper definitions, which is going to get better when we add proper versioning for each model. That's coming soon. It's in a McNeil traditional sense. But yeah, once the models are uploaded to your account, there's several things you can do. So the first, and by default for most accounts, when you upload models, they're private, right? So all of these models are private, which means I'm the only one that can access them. But I always have the ability to make a model public. And for example, this one, you can see with the color here, but this one is a public model, which means that if I go to this model and this model has a URL, I can share it with anyone, even if they don't have a ShapeDiver account, right? So that's the first way you can share an application. But obviously, in a lot of contexts, it's not ideal. Well, first of all, you might not want the app to be public if you're working on some IP or some confidential projects or whatever. But also, this means open the app in the ShapeDiver platform with everything it includes. There's a lot of data about the app, like some API keys and stuff. So that's not the, let's say for a lot of workflows, it's not the most comfortable to directly share like this. So from this, we have a wide range of options depending, and again, that depends on the use case, on the context, on the way you want to collaborate or share this with partners, clients, colleagues, etc. But the second, let's say, if we progress in the order, the second thing you can do is in the context of having an app that's private, so that you don't want to make public, but that you want to share with users that do not have a ShapeDiver account, which can happen, right? So you can have, I can quickly mention later the organizations. If you have an organization, you can always make things visible to your entire organization or share with people inside the organization. But in a lot of contexts, you might want to share something with someone that does not have a ShapeDiver account. And the first simple way to do this is to enable link sharing. So that's something you can do if you, while keeping your model private, right? You can here enable link sharing and save the model. And if you do this, your app again can be found by nobody on the platform. But if you can use the share option here to get a link, which is this like private link, right? So it does not show the public URL of the model. And anyways, this URL does not work for private models, so no one can access it. But here you get like this private link that you can directly share with people. And it's a bit like if you're using Google Docs or whatever, it's a share on only people with the link, right? So people have to have the link to be able to open. And you can share the link directly to the model. So here inside the ShapeDiver platform, or a link to the associated app. So for example, if I open this and I open a different web browser where I'm not logged into ShapeDiver, I can open this link. And that's a link that anyone can open, even if they don't have an account, if they're not logged in or whatever. So that's like a first way to share, to give access to the application. The second way is to embed applications. And in this case, we also have several options. The first option is to use, but right now it's a bit intricate to do it with apps. So we can also do it with apps, but mostly with the model directly. You can copy and paste an iframe code here and embed it in any website, your WordPress website or SharePoint if you have one, or some intranet in your organization. And here you really don't have to do anything. Yeah. Question?
Oh, just so all the functionality that is built in the ShapeDiver or the app builder, will that show up in the iframe?
So here we're in the process of basically implementing the same workflow for the apps as we already have for the models. So here, if you copy the iframe code, what you're gonna get is essentially a version of this page reduced with just the viewer, the parameters that you can embed anywhere, the one-to-one, what you see here.
Gotcha. Okay.
Right now, there's no direct way to copy and paste and embed the iframe, but that's gonna come soon.
Okay.
But you can already embed the app by enabling embedding. So let's say here, I'm gonna allow direct embedding in my model. And what you need to do is first this, so enable embedding for the model, and then go to your settings. And here we're getting to the features that are not available in the free plans. So in the free plans, you can build your apps, you can see that everything works, you can test everything, but you cannot, all these sharing features are for the premium shader subscriptions, which again, you can start a trial for and start using it and test it also. But here, the second step, so is enable embedding. And then if you go to the embedded settings here, is to whitelist the domain, so the website where you want to embed this app, right? And that's where the premium features come, because you have, there's no domains available for free plans, but then if you go to designer, there's like 1 or 2 domains, and business more. So you can define domains here that are allowed to embed the app, the model or the app or anything externally, essentially. So for example, that's what I do here. I allowed the W3 schools domain here because that's the page where I test my iframes all the time. And here you can, so again, I'll show how it works for the model directly, because it is how it's going to work also for the apps soon. But for now, for the apps, there's a couple more steps. So if I go to this one, and I go iframe, I can, and by the way, I can customize my iframe a bit with colors. I can brand it a bit. I can add a logo. There's some options, but here I can just do iframe. Sorry, I have to do this all the time because the zoom toolbar on top is unrolling. And here I get my so the traditional ShapeDiver model embedded. So here it's with this this layout, because I'm so if I do this, it's with this. So it adapts, it's responsive as well, right? So here that's just like copy paste iframe. It works for the model. And at the moment, if you want to do this with the, well, essentially it already works, but there's just no copy paste button on the platform yet. But here there's a page in the documentation called embed apps in external websites with a bit more information. So everything I'm showing now. But essentially, if I here copy this code and replace here the slug with my model slug. So here, for example, this one. It should work to embed the app directly. Exactly. And it's the same, the layout adapts right here. So here you have already the mobile version, but you can also embed your app. So the only difference is that right now, again, there's no iframe, copy paste and stuff. And also that you need to enable the embedding in a developer side, which requires, it's from the Designer Plus account. So it's not like the smallest, the cheapest ShapeDiver account. It's the one above. But that's the one that allows you to do this. So that's the second way to share, essentially, with users that do not own a ShapeDiver account. You can embed it on a website, and then obviously this website, you can control who has access to your website. You can also hide it behind a paywall, for example, something like this. yeah, now we can look at the other ways. So as I mentioned, if you're part of an organization, so actually I'm not part of an organization, so I'm not going to go too deep in this feature. But if you're part of an organization, there's the library of the organization that you're part of, private library. And then you have one more option here for the visibility of your models. So here I'm not in an organization, so I can only make models private or public. But if you're part of an organization, there's one more option called organization, where you can decide, I don't want my model public, but I want it to be visible to everyone that's part of my organization. So that's a third way in case of organizations to, let's say, quickly show to your entire organization or entire team. We have this feature where you can split the organization in teams and directly share with specific teams. And the last way to share a model is to use direct sharing. And that works also, like for organization, it works with people, even if you're not part of an organization, it works if you want to share with someone who also has a ShapeDiver account. And here, and again, it's more fine-grained. I'm gonna show it now. But the idea is to extend this level of control over the apps to the other ways of sharing, but right now it's only available in this way. So here, if I go here in the sharing tab of my model, and I want to add a user, for example, my colleague Alex. Of course, there's a lot of Alex, so Alex and she now. All right, for example, that's not his main account, but and then I can control. So here I'll just do this because I can still edit this after. But I can control fine-grain what sharing means, which means what features of my app the user I shared with has access to. So view is typically needed, right? The users need at least to be able to open the model and see it and see the parameters. But you can also control if these users can use the export buttons, so the ability to export assets from the model. The ability to download the Grasshopper file, to see analytics of the model, and to use the model in desktop clients, which is a feature that we're not going to go over today because it's a really different thing. But essentially, desktop clients is the ability to interact directly from Rhino or Adobe Illustrator or other software with ShapeDiver apps, right? And bake directly what an app has in the document of another software. But essentially, in this case, and that's going to come also soon for the other ways of sharing, that you, for example, can fine-grain control for this user. I just want them to be able to see, but exporting is maybe reserved for close colleagues or clients, I don't know, that paid or whatever. Like there's a lot of scenarios that you imagine. Yeah, and let's say since I focused the whole workshop on creating extremely flexible web applications that you can deploy at low effort and share with the users or embed in website and stuff. I guess obviously I should mention the last possibility, which is well, one of the possibilities we had very early on in ShapeDiver, the ability to what we call directly embed, so direct embedding of ShapeDiver models, which comes with the viewer API. And in that way, you essentially use the ShapeDiver model in the backend and the viewer if you want it, but you don't have to use the viewer as a sort of remote API around which you can completely custom build your own application, right? So if I go, for example, to clients, I never know which ones I can show easily, but let's say cake houses. So that's a website that was built already for a few years ago using ShapeDiver. And here we have a company that has used the viewer API to embed the ShapeDiver viewer in the context of the API. And they built their own completely custom UI around the model, right? So that's something you can do with standard, web development skills, JavaScript, HTML, JavaScript, and build a completely custom interface. Here, I think, for example, so that's more noise, but here, show that. And also you can control everything in the viewer. So you can, for example, link buttons to like camera movements and even animations. So some clients have built things with animations. Again, I'm not sure which ones. This one, but I think, yeah, okay, the website is down. So basically, extremely advanced applications that are completely custom built around a ShapeDiver model. And that's always possible. That's always going to be possible for the simple reason that, well, essentially, we historically had those two options, right? And I should probably have started with this. The option to show ShapeDiver models inside the platform, this interface, this static fixed interface. And if that's good enough for your application, if you don't care too much about how it looks and stuff, or if you don't have to interact with geometry in the viewer and do complex stuff, then that's enough. If you cannot do that, then build your own configurator using our API. All the geometry, the parametric logic and stuff is still in the model, so it's handled. The only thing you have to do is use web development to build a custom interface, which is a skill that a lot of web developers have anyways, and have an interface with our models in the back where you can just say, okay, I want to send these parameter values, sliders and stuff, and get back geometry or file exports and update that in my interface. And what we've seen over the years, obviously, is that this is a huge gap between what Grasshopper experts can do with just Grasshopper and something that immediately needs the help of web developers and people more experienced in what a web application entails and what it's like. So the app builder has been our attempt right now to bridge the gap between those two things. And the driving idea is that we develop this in a lean way to already, after we've started working on this less than a year ago, to already quickly provide some much more than what is historically available in a model view page, traditional model view page. And you've seen that includes also interacting with geometry in some ways, organizing the interface with more flexibility. But obviously, it's a work in progress that with time will look more and more at use cases and what needs to be done by Grasshopper experts that then hit the roadblock of having to use the API to build the entire web application, right? So here, that's a part where getting feedback from you guys from the community as you build apps about what's missing and how we can improve the framework so that it achieves its goal essentially of letting Grasshopper experts deploy end-to-end web applications without having to use any code essentially. And yeah, I think I'm gonna, because I really went a lot faster than the last time. So I think I will stop sharing for now. If any of you have a few questions now, I'm happy to stay for a little bit more, and then I can release you to your important work.
Thank you very much, Matthew. Very great work. So you will share those Grasshopper scripts to the Google Drive,
Yes,
right?
so well, I have the list of participant emails, so I'll send an email anyways with the proper links to documentation that we have. And in the Google folder of the webinar, I'm gonna add the second example that I have. I'll just make sure this was Twitch that I just noticed is not in there yet, so that it's fully functional. And maybe a couple of other examples directly. But the other examples are anyways in the help center of ShapeDiver, so that's easy to get. And I think so. This session is recorded, so I think that's also going to be available to everyone in a few days, probably. Yeah.
Sure. So if you have time, can you please share some experience about how to improve the running speed of our ShapeDiver app? Because we experience some speed issue. I mean, sometimes I run app, it takes pretty much a long time to refresh the results when we updated the input.
Yeah. Yeah. So that's what we've seen more in the context of complex applications in the AEC industry, especially now because I didn't spend some time on this, but if I share my screen again, I mean, that's maybe not necessary. But one of the plugins that we support is Swiftlet, which was blocked by Sergey in the core studio. And that's a plugin that allows to make, API requests directly from Grasshopper. And what we've seen at TT and from other applications is that it allows to call some pretty complex machine learning algorithms, for example, or daylight simulations or this kind of operation that takes a long time. So that's one of the reasons that some more complex algorithms can take longer. So on ShapeDiver, depending on the account you have on ShapeDiver, there's different limits to the time it can take to compute. Typically for enterprise like TT, there's no limit, there's no more limits, but for the basic accounts, it's like 10, 20, 30 seconds, 1 minute, etc. So that's if you're making use of this sort of algorithm that are executed anyways outside of the ShapeDiver environment, it's difficult to optimize for this. But of course, when you look at a Grasshopper model locally, sometimes you can notice some differences in terms of performance after it's uploaded to ShapeDiver. And there's several reasons for this, and I can go through a few of the standard ones. So essentially, when you're in the context of an app or the model on ShapeDiver, what happens when you update a parameter? Well, what happens is that you package that as an API request that you're going to send to the servers. Then, if the request, so that's a good thing about ShapeDiver is that we do a lot of caching. So if you open a model and someone requests a set of parameters that was already requested in the past, then our caching systems pulls the result directly, which is typically instant. It's very fast.
Yeah.
It can still take longer for other reasons that I'm gonna go on in a minute, which is mostly the size of the geometry that you're putting, but otherwise it's very fast. If it's not cached, it's gonna go to the backend servers and compute there. And what you have to know that is on ShapeDiver, the reason why ShapeDiver can scale to so many users, and even we have clients that use it for e-commerce websites where there's like thousands of users every minute using the configurator and stuff. And that's because the ShapeDiver system is like an auto-scaling system where there's like a lot of servers. And if the system is full, there can be more servers that spin and start computing. And the first thing that can delay the model is that it's going to a server where the model was not already running, it was not already open. So it means the instance has to open the model, which means that sometimes, and again, it's different. For example, for TT, if you just have 1 or 2 servers and all the models are preloaded, that's not the case. But a lot of the times, when you send a computation request, a new one, it's going to take as long as the first time you open the model in Grasshopper locally, right? And we know that that takes longer typically for several reasons. I mean, when you have a model open and you upload a parameter I made the same mistake. But if you update a parameter, it's only going to trigger the computations for the parts of the definition that depend on this parameter. But since on ShapeDiver, when you change a parameter, it might open on a completely new server, it's going to recompute the entire definition. Right? And it just comes with the cloud environment and the set of servers that you make use of. The second thing is that when you open a new model, one operation that happens and that takes a while is in case you're using a lot of scripts, C# scripts, they have to be compiled, and that takes a long time. That's why we're trying to support as many plugins as possible, because custom scripts obviously are powerful and let definitions do a lot of really advanced custom things. But compiling the scripts, if there's a lot of scripts, it can take a while. Then there's the execution of the code script itself, which typically on the servers, when you're at this stage, will take the same time, maybe a bit faster if you want good servers, take the same time as it takes when you compute it locally. So for example, here I made the mistake of taking this parameter too low, and it's probably going to take a minute to compute now. And that's, you can reproduce on ShapeDiver. And the last thing is that then when you go to the outputs, so the geometry that you display in Viewer, obviously this geometry is computed on the backend servers, and then it has to make its way to the front-end application, right? So it has to be computed, sent to our caching system and stored there, and at the same time sent to the front-end browser that users are using, and downloaded there. So if the geometry is several megabytes big, you have to download several megabytes, and depending on your connection, that can take a bit of time, right? So that's typically time that you don't experience, of course, when you're working locally with Grasshopper. So that's why we have, we recommend always, well, now I crashed my Rhino, but we always recommend to pay attention to the geometry that's sent. So first of all, to use the display components of the ShapeDiver plugin, which turn all the geometry into GLTF files, and pay attention to the geometry that's sent. If possible, mesh it. So put it already in the forms of meshes and polylines and curves, and make sure that the geometry you display, that the meshes, for example, are not unnecessarily big, right? So if you're starting to want to display meshes with millions of vertices, it's natural that it weighs heavy, maybe 100 megabytes, and that you have to download this every time. And the thing is that what we experience is that in a lot of cases, users tend to, in applications where there's the need to export files, the exports need to be detailed, right? So for example, if you have a 3D printing application, you want really refined meshes to export. But what you display in the viewer does not need to be so refined. You just need to display what looks good for your application, and often it can be much smaller, coarser meshes, which speeds up obviously the the updates and the whole flow of data between the web browser and the servers. I think in terms of optimization, that's pretty much it. Then there's like optimization of Grasshopper per se, right? So make your definition in general faster. For this, we have a lot of videos and tutorials and stuff. There's a lot of operations you can try to avoid. There's a lot of tricks. Actually, my colleague Edwin just gave a webinar about this, about things that maybe designers are not aware of. Take a long time to compute, but there's workarounds to make it faster. So that's also a link I can send to all the participants of the webinar after the session.
So if I let's say sometimes we hold the hands-on workshop and maybe there are 20 or more participants using the ShapeDiver using the same ShapeDiver app at the same time. So in that case, could the speed be impacted by so many users using it at the same time?
No, it's not going to be impacted because it doesn't matter that it's the same model.
Oh.
All these users are using separate sessions, and so it's not different than on the shared servers of ShapeDiver right now. If I go to the public gallery, that's what I see. We have, in average, I think 500 new models uploaded per day. We have tens of thousands of users using the servers. So if you have a workshop with 10 participants using it at the same time, that's nothing compared to the usage that's made of ShapeDiver in general. So that's really not an issue.
Thank you.
Sure.